Welcome to the deep dive. Today, we're plunging headfirst into something that's, well, genuinely reshaping how businesses handle their most critical asset, data. We're talking about Snowflake's hybrid tables.
That's right.
For years, data management has faced this fundamental dilemma. How do you get the blazing speed you need for everyday transactions? Think of like a retail checkout.
Yeah, the operational stuff.
Exactly. And how do you combine that with the deep analytical power you need for, big picture insights, like analyzing quarterly sales trends?
They've always been separate worlds, haven't they? OLTP and OFE.
Oh, totally separate, optimized differently, forcing these complex, kind of slow compromises.
Yeah.
Well, the aha moment of finally unifying these worlds might just be here with hybrid tables. Our deep dive today is based on some really great source material, detailed excerpts on hybrid table implementation in Snowflake with streaming and batch sources.
And that's precisely the challenge, isn't it? You've got operational databases, OLTP, built for speed, consistency, small frequent changes like processing one order.
Right.
Then you have analytical databases, OLAP, designed for these massive complex queries over huge historical data sets, perfect for finding patterns across millions of orders.
Two very different jobs.
Very different.
Yeah.
And trying to build a single engine that's both, a dragster and a cargo train, it always felt impossible.
Yeah.
It typically means complex pipelines, data delays, just a constant struggle to keep everything in sync.
Which kills real-time use cases.
Absolutely. And this is where hybrid tables really promise to be a game changer. There's a great quote from Anjali Mehta, VP of Data Engineering at the FinTech Corp.
Oh, yeah.
She says, Snowflake's hybrid tables have given us the transactional speed of OLTP with the analytical depth of OLAP all in one place. It's redefining how we build real-time AI-powered applications.
Wow. Okay, redefining how we build real-time AI-powered applications. That really captures it.
It really does. That's the core idea we're digging into.
That quote definitely hits home. The idea of designing one architecture that seamlessly handles both that real-time data flow and deep historical analysis. I mean, that sounds like the holy grail for data folks.
It kind of is, yeah.
So when we talk about this unification, what specific capabilities are we truly talking about here? Like, what does having it all in one place actually let you do?
Right. It's about combining these distinct powers, really. So hybrid tables are designed to support several critical things simultaneously.
Okay.
First, there's real-time ingestion from streaming sources.
Right.
Think continuous, high-speed data, maybe from Kafka, AWS Kinesis, Azure Event Hub, those kinds of platforms. Digital highways for data, basically.
Got it. The fast stuff.
Exactly. Then there's also periodic congestion from batch files. Those big CSV or Parquet files you might dump onto S3 or Azure Blob Storage.
The bulk loads.
Right. But it's not just about getting data in. These tables offer low latency querying. Super important for powering instant responses for things like ML inference.
So the models can use fresh data.
Instantly.
Yeah. And also for operational dashboards that update in real time or quick reports.
Makes sense.
And maybe the most critical piece, they enable ACD-compliant transactional rights and updates directly within that same table.
ACD compliant. So reliable transactions,
Yeah.
like database guarantees.
Exactly. Like a bank transfer. It ensures data integrity. Either the whole change happens correctly and permanently, or nothing happens. No partial updates.
Okay.
And achieving all of these streaming, batch, fast queries, reliable writes all in one place, that's really significant for modern data needs, where everything needs to be immediate and intelligent.
That's a powerhouse combination, no doubt. It's one thing to talk about these capabilities, but what does this actually look like under the hood? Can you sort of pull back the curtain and walk us through the conceptual architecture? How does it all fit together?
Absolutely. Think of it like a really well-designed data flow system. It starts naturally with your sources.
You've got those high-speed streaming events data constantly flowing from platforms like Kafka or Kinesis, like a river, always moving.
The real-time feed.
Yep. And then you have your batch files, which might be those larger data dumps from external storage like S3 or Azure Blob, more like a scheduled delivery truck.
Gotcha. Stream and batch.
Next stage is ingestion. How does this data actually get into Snowflake?
All right.
For the real-time streams, you typically use something called Snowpipe streaming or maybe partner connectors. It's like a direct express lane for low latency entry.
Okay, fast lane.
For the batch files, you'd use the copy Y into command. That's more like your scheduled bulk loading from those external storage spots. Your loading dock, if you will.
Makes sense.
Then the heart of the system, the hybrid table itself, sitting inside Snowflake. Now, what's really crucial here is that these are row-oriented tables.
Row-oriented. How's that different?
Well, think of a traditional spreadsheet. Each row is a complete record. This structure is optimized for quickly adding new rows or updating individual ones, exactly what you need for those fast transactional kinds of operations.
Oh, okay. Faster updates.
Exactly. So once the data is in, we move to processing. Inside Snowflake, you can use standard SQL, which is great, plus automated scheduled tasks. Think of them like little robots doing things on a schedule and streams, which capture changes to data. All used for real-time enrichment, deduplication, transforming the data as needed.
So you can clean and prep the data right there.
Right there, often in near real time. And finally, the consumption layer. What does all this unified data power?
The outputs.
Yep, operational reporting, dynamic dashboards, and importantly, things like machine learning models, Snowflake's own Cortex AI features, semantic search, advanced stuff.
Wow.
What's really fascinating, I think, is how all these pieces, sources, ingestion, the row-oriented table, processing, consumption, just work together seamlessly. Data flows in, gets processed, stored, and is immediately ready for both quick transactional needs and deep analytical queries.
Okay, that architecture makes sense. But here's where it gets really interesting for me. Concepts are great, but can you maybe paint a picture with a concrete example? How would this actually work in a business system?
Sure, let's take an order processing system, something pretty much everyone can relate to, right?
Yeah, definitely.
So imagine, on one hand, you've got new orders, status updates, maybe shipped, delivered, streaming in constantly from something like Kafka. Every click purchase update arrives in real time.
The live events.
Exactly, that's your continuous flow. But then maybe you also get daily.csv files with, say, legacy orders from an older system, or bulk return data, or inventory adjustments, dropping into cloud storage like S3.
The batch load again.
Right. So the hybrid table becomes the central single source of truth for all orders. It intelligently merges these two flows.
How does that merge work?
Well, new streaming orders get inserted almost instantly. Updates to existing orders, maybe a changed address, or that shipped status update, whether they come from the stream or the batch file, they're applied immediately to the right order record in the table.
So it keeps the order status completely up to date.
Exactly. Sub-second updates are possible. So if a customer just placed an order, boom, it's in hybrid table.
Yeah.
If they then call support 5 minutes later to change the shipping address, that update hits the table almost instantly.
Okay, that's fast.
And crucially, this consolidated up-to-the-minute view is immediately queryable. You can run traditional analytics, how many orders this hour, but also ML scoring. Is this new order potentially fraudulent? Or what's the predicted delivery time based on current logistics?
Ah, so the AI models get the live data too.
Instantly. You could even have an AI agent powered by this live data, maybe proactively suggesting alternative shipping if the delay pops up in the stream. It's a single source of truth that's live and ready for, well, pretty much anything operational or analytical.
That's a fantastic example. It really brings the concept to life, seeing how stream and batch converge into one usable live table. Okay, so for listeners thinking, maybe we could use this, what's the general workflow? If you're actually implementing one of these, can you walk us through the high-level building blocks?
Sure. It sounds complex, but the setup in Snowflake is actually pretty straightforward, mostly using familiar SQL. At a high level, there are a few key steps.
Okay.
First, you typically set up a staging area. Think of this as like a temporary holding zone. Often it's just another regular Snowflake table. This is where your incoming streaming data, say from Snowpipe streaming or a Kafka connector, lands initially.
Why the staging step? Why not go direct?
It just helps decouple the rapid, potentially messy inflow from your main, clean, final table, keeps things organized, and allows for some pre-processing if needed before the merge.
Got it. Buffer zone.
Kind of, yeah. Next, you create your actual hybrid table. This is the main event, the final destination, that consolidated view of orders we talked about.
Yeah.
You defined its structure columns, data types, and crucially, you'll usually define a primary key.
The unique identifier, like order ID.
Exactly. That ensures each record is unique and allows for efficient updates. You'd also likely add some useful metadata columns, like maybe source type, was it stream or batch, and last updated timestamp. Very helpful for tracking things.
Good practice. Okay, staging table, hybrid table, then what?
Then you start ingesting your events. Data starts flowing into that staging area we created.
Turn on the taps.
Pretty much. Now, the magic part,
Hmm.
You automate the merging process. This is usually done with a scheduled Snowflake task. Think of it as a little automated job.
Scheduled like every minute.
Yeah, typically something frequent like every minute or even more often, depending on the need. This task runs a merge into SQL statement,
Hmm.
and this statement is smart.
How so?
It looks at the data in the staging table and compares it to the hybrid table based on that primary key. It basically says, if I find a record in staging that already exists, matches, in the hybrid table, I'll update it with the new info. If it's a brand new record doesn't match, I'll insert it.
Ah, so it handles both updates and new entries automatically.
Correct. Keeps the hybrid table perfectly synced. Then you just enable that automated task so it starts running on its schedule. And finally, you'd probably set up some simple cleanup rules for that staging table just to clear out records after they've been merged so it doesn't grow forever.
Okay, makes sense.
So the basic flow is data streams into staging, the scheduled merge task moves it into the final hybrid table every minute or so, keeping it constantly up to date and live.
That seems quite manageable, actually. But this sounds incredibly powerful. Very dynamic, real-time updates, potentially sensitive customer order data. With great power comes great responsibility, right?
Mhm.
How do we manage and secure a system like this? What about governance?
That's a critical question, absolutely. And Snowflake has put a lot of thought into this. For governance and observability, there are several tools. You can track data lineage, understanding where data came from and how it changed, using features like Snowflake's access history and the information schema.
So you can trace data back.
Exactly. For an audit trail, those metadata columns we mentioned, like last updated and source type, are invaluable. You can also set up robust error handling, maybe redirect rows that fail the merge process into a separate error log table for someone to investigate later.
Instead of just failing the whole batch.
Right. And for monitoring the system's health, checking if things are running on time, you can use Snowflake alerts combined with tasks to monitor SLAs, performance, things like that.
Okay, good governance tools. What about locking it down? Security.
Yeah, on the security and access control side, it's quite granular. You can apply row-level security policies, meaning even if someone has permission to query the order hybrid table, you can set rules so they only see the rows they're authorized for, maybe based on the region or department. Critical for sensitive customer data.
Definitely.
Then you use standard Snowflake roles and grants to give different teams, developers, operations, analysts, just the permissions they need. Nothing more.
Least privilege principle.
Exactly. And you can also use object tagging. You can tag columns containing personally identifiable information, PII, or other sensitive data, which helps with discovery, masking, and applying security policies consistently.
So a layered approach to security.
Very much so. It ensures that even with all this speed and agility, the data remains secure, governed, and auditable.
That's reassuring. It sounds like a really comprehensive approach to managing such a dynamic system. So, okay, let's pull it all together. When you look at all these pieces, the architecture, the implementation, the governance, what are the overarching, maybe transformative benefits for organizations that adopt this, it feels like it goes beyond just, faster queries.
Oh, it absolutely does. The benefits really compound.
Mhm.
First, obviously, there's latency. You're talking sub-second updates potentially from streams. Insights aren't hours or minutes old. They're truly current.
Real time, for real.
Yeah. Then the flexibility is huge. Easily merging historical batch data with that live, real-time data gives you a complete picture, always. No more stitching things together manually.
That unified view.
Exactly. There's also simplicity, surprisingly. Because it's a native Snowflake feature, using standard SQL, it often reduces the complexity compared to managing separate OLTP and OLAPE systems and the pipelines between them.
Less moving parts.
Fewer moving parts, familiar language. It also offers massive scalability. Snowflake's architecture is built to handle millions of events per second and huge batch files, so it grows with the business.
Future-proof, hopefully.
Designed to be.
Mm.
And finally, maybe the most exciting part for many, it's inherently AI-ready. It acts as a live feature store.
Feature store for machine learning.
Exactly. It provides your ML models and AI agents with up-to-the-minute, fresh data features for making predictions or taking actions. This isn't just about faster data pipelines. It's about enabling proactive AI.
Proactive AI? Like what?
Like fraud detection models catching something suspicious as the transaction happens, not after the fact. Or supply chain optimization automatically rerouting logistics the instant a new constraint appears in the data stream, not hours later when a batch report runs.
Wow. Okay.
It really connects back to that Anjali Mehta quote, right? Redefining how you build real-time AI applications because the data is live and integrated.
It's incredible how much ground we've covered. And yeah, that powerful point about redefining real-time AI, the quote from Anjali Mehta, it really does bring it all together, doesn't it? This idea of unifying operational and analytical data with Snowflake hybrid tables, it feels like much more than just a technical upgrade.
It really is a shift in thinking.
So,
Yeah.
thinking about our listeners, what does this all mean for you in your own fields or areas of interest? How might this change things?
Well, I think this approach isn't just about, technical efficiency or building slightly better databases. It's really about fundamentally changing the speed and the agility with which organizations can build and deploy intelligent
Speed
applications.
and agility.
Yeah. It's about making data truly live, ready to inform decisions, power AI in the moment, rather than just being this historical archive you analyze later.
Right.
And that, I think, raises a really important question for everyone listening. What new possibilities open up for your business or your projects when your analytical data and your transactional data are truly one? When you have those instant insights ready to fuel your AI initiatives, what could you build then?
A truly thought-provoking question to end on.
Right.
What becomes possible when that gap is finally closed? Fantastic. Thank you so much for walking us through that.
My pleasure. It's exciting stuff.
It really is. And thank you, the listener, for joining us on this deep dive into Snowflake's hybrid tables. We definitely encourage you to keep exploring this fascinating intersection of real-time data, AI, and modern data architectures.